Off the grid campers, this is part 2 of the eFusionBlue video. In this video we're going to drill down even further and we're going to look at the safety aspects of this system. The safety of the system is very much reliant on the quality of components. Number 1, we use the Victron gear. Number 2 is the cabling, the sizing, the brand of cabling, and then of course how you crimp it and terminate it with lugs and boot lacing, as well as sheathing it, protecting it with heat shrink or covers or conduit, whether it's split tubing or hard tubing in case of the 240. We have other things as well, like a heat alarm up here in the electrical bay that will go off if there's a rapid rise in temperature. We'll go down into more detail on 2-pole and the mains distributor. So if you follow me around, we'll just start with, once we've done it all, one of the last checks we do is to check the temperature of the connections. You've just got everything from a basic laser thermometer to more sophisticated thermal imaging camera. So we can check to make sure, we got this turned on, the cable connection there is running at 24 degrees. Just to make sure that all of the components aren't overheating, and if there is a hot spot there, you want to try and eliminate it, because multiple hot spots, heat being resistance basically being loss of voltage. So you start losing 0.1, 0.2 here and there, you start losing a lot of your charge. So it's very important to do all this correctly, as well as securing all of the gear to the appliance plates inside. It's all riv nutted, which is essentially like bolting it into those plates, but the nut gets inserted and then the bolt goes through into that. So it's a very clean way of doing it and very strong. So cabling, we use, and we've touched on this in another video, the cool drive cabling, everything from your 6 BNS. We talk in millimetres square. I mean, you've got US system, you've got Australian system, BNS, but you've also got, essentially it comes back the common denominator of the square millimetre of the cable. So 13 mil square, 70 mil square, 95 mil square for things like your inverter. We even double up on this 95 mil square. You can see just how thick that is. That's all the copper and the sheathing around it. So the quality of the cable, very important. The sizing of the cable, very important. A lot of people say, oh, this is overkill, you're putting too thick a cable in. What they fail to consider though is a 40-degree day running your inverter, which is drawing power from your batteries, for several hours at a time. So you've got ambient temperature, you've got constant load, that derates the capability, amperage. This is like 300 amps. But you know, everything's always under ideal conditions. So when people tell you ratings and sizings, it's always under ideal conditions. And of course, in Australia, you know, in the middle of summer, in the outback, it's certainly not ideal conditions unless you're a reptile. So hence we size the cabling according to kind of a worst case scenario, so that you can run this gear under full load for you know, quite a period of time without it getting hot. Similarly with the DC charging cable from your vehicle, we use like a 6 BNS, which again, 13 mil square, we get told it's too much because it's rated to 100 amps, but you've only got a 50 amp charger, but under your bonnet it gets pretty hot, and if you're running that for several hours at a time, again starts to derate. So that's the one thing I'll say in response to some of the, it's not criticism, it's just a different school of thinking. I've been doing electronics for 30 years, so I know this stuff reasonably well. You've got to factor those scenarios in. So that's cabling. You've got connectors down here. I said we conduit everything as well, whether it's the hard corrugated 240 conduit, whether it's just 12 volt cable goes into split tubing. I mentioned connectors before, so you've got your smaller lugs And you'll see I've pulled stuff out of the drawers here. I'll get in trouble for this, but I'll put it all back, I promise. Up to larger lugs. And these are the lugs that go on to the bigger cables. Here's ones we prepared earlier. That lug needs to be put on there very securely, because you don't want, through vibration, it coming undone. So you can see how we've crimped it in like 3 or 4 places there with this guy. So that's what gives you a really tight connection. When you do that 3 times, you could swing off that. It's not going anywhere. And then we heat shrink after that. So the heat shrink goes on there. And then heat shrink it down. You see it creates quite a tight connection. There's different grades of heat shrink as well. There's single wall, double wall. We use all the double wall stuff. It's sort of like a marine grade heat shrink. Just goes on there and seals it much better. This is a bus bar we made up to be able to do this at right angles. This is our main bus, which you saw in part 1 of the video. And so this one's been made up. We make a lot of stuff up on the bench simply to save time. But again, this is all bolted internally, and you can see the thickness of the copper, because I mean, this is all 1000 amp rated. So if we introduce our own custom parts, it's got to, you know, be sufficiently capable of pairing in with everything. But in terms of, you know, the strength of it, like that, you know, that's all of that just bolted together, and then it gets bolted to the wall. So that's not going anywhere, and it's certainly not coming apart. The boot lacing, which are these connectors here. So these are a different style of connector to your lugs. That's a lug. That's a ferrule that we call it boot lacing when we put the cable on. And then it goes into these type of connectors. And if you boot lace it, it never comes undone. You don't just put bare wiring in, you know, twist it and screw it down. That'll come undone after time. So all of these, the MPPT and the DC-DC charger, these things, it'll take your boot lace connections. So again, cables not going anywhere once they get screwed in. This is the 240 enclosure that we showed you in the last video. So you've got your safety device there. This is made by a company, for us in particular. We took quite a bit of time in designing it with them. They're called PowerSafe. They do a lot of electrical equipment for Queensland Railways, and I think the Defence Force and mining companies, because they have a part that detects voltage on the earth circuit. So in a high impedance or environment where you've got no earth stake in the ground or it doesn't work, in the case of our camper, you don't have to plug your earth stake in, or you're not plugged into the grid to get earth. That'll detect voltage on the earth circuit. So all the earths are wired back to this, and that's what trips in terms of, you know, tripping your safety switch. Otherwise it works as a normal safety switch. And then if I put the cover back on, you'll see what it looks like in the camper. We haven't labelled this one, which we maybe showed them in the one that's in the enclosure here. You've got the smaller circuits broken down into hot water, general power and air conditioning. So that allows you to isolate a fault and generally makes it safer rather than throwing everything onto the one circuit. Not a good idea. Fuses, we spoke about fuses before. The fuses, I didn't take the cover off this, I probably should have, but inside, essentially there's a fuse, goes over the positive, and then the light will go on if the fuse is blown, indicating there's a fault. The other connections will keep running. So if you've got 4 batteries hooked up and one fails, a light will come on, but the other 3 will keep going happily. So from a fault finding point of view, it's good, but also from a redundancy point of view, it's good because it's not going to shut your whole camper down. That's why we fuse everything and isolate everything, because at some stage you may well get a fault, but it's not going to disable your entire system. So we've got a range of fuse sizes for different items, different components. Your blade fuses, these are your smaller fuses for your 12 volt items. The conduit, we covered all of that. So essentially that's the safety aspect of building the eFusionBlue system and what we do to make it safe for off-road and off-grid use. Thanks for watching, and we'll see you in part 3, the final part of this series.